Turbulence. A disturbance to the direction of the wind in a horizontal or vertical plane. A squall is a sudden increase in wind speed of at least 16 knots to a uniform speed of 22 knots over at least 1 minute. A gale is a sudden increase in wind strength with a minimum speed of 34 knots. A gust is a sudden increase in wind strength lasting less than 1 minute with a minimum wind speed of 43 knots. Vertical wind shear. Wind shear is a sudden change of direction and or speed of the airflow. Its occurrence is created by any meteorological situation that will cause such sudden changes. Units of knots per 100 feet are used to report vertical wind shear. The following meteorological factors can cause wind shear: inversions, katabatic winds, air mass fronts, low-level jets, and jet streams. Horizontal wind shear. Horizontal wind shear is a change of wind velocity with distance. Wind shear with an increasing headwind. An aircraft has momentum, and if there is a sudden change in wind speed, then the speed relative to the air changes abruptly. The true airspeed increases if the headwind increases or the tailwind decreases. The result is an increased lift and an increased drag. The nose goes up and the aircraft climbs. If properly trimmed, the aircraft will level out above the original flight path, and the ground speed is reduced by the size of the wind change. During an approach, the engine power must be reduced for the aircraft to return to the glide path, or an overshoot may result. Wind shear with a decreasing headwind. The speed, true airspeed, decreases when the headwind decreases or the tailwind increases. The lift decreases and the aircraft descends, but a properly trimmed aircraft automatically assumes an increased angle of attack and levels out below the original flight path. To return to the original flight path, increase the power distinctly. Note that the ground speed has also increased or an undershoot may result. Severity of turbulence. The severities of turbulence are light, moderate, severe and extreme. Light causes momentarily slight erratic changes in altitude and or attitude, pitch, roll, yaw. Accelerations are less than 0.5 g. It's noticeable that occupants may feel a slight strain against seat belts. Food service may be conducted and little or no difficulties encountered in walking. Moderate, there are changes in altitude and or attitude, but the aircraft remains in positive control at all times. It usually causes variation in the indicated airspeed. Accelerations between 0.5 and 1 g occur. Loose objects move about in the aircraft. Occupants feel a definite strain against seat belts. Food service and walking are difficult. Severe means large abrupt changes in altitude and or attitude. Large variations in indicated airspeed. The aircraft is uncontrollable during short periods. Accelerations are more than 1 but less than 2 g. Occupants are forced violently against seat belts. Loose objects are thrown around. Food service and walking are impossible. Extreme is where turbulence in which the aircraft is violently tossed about and is practically impossible to control. It may cause structural damage. Accelerations are more than 2 g. Dealing with turbulence. If convective currents are encountered during a flight, you should attempt to reduce speed and try to climb above the zone of convective currents if aircraft performance parameters allow. Normally, the most effective measure to reduce or avoid clear air turbulence effects is to change the flight level. Turbulence. Turbulence can occur in clear air, mostly around jet streams. In clouds, convective currents, vertical currents caused by uneven heating of the Earth's surface, are a form of thermal turbulence. Friction layer. Turbulence may result from friction between the air and the ground. Wind factors. Wind is air moving in horizontal and vertical motion. Differences in temperature cause pressure changes, and these in turn affect the wind system in an airflow. The pressure gradient force is the force caused by the pressure difference, i.e. from high to low. A gradient wind is slower around low pressure and faster around high pressure. The geostrophic force is caused by the rotation of the Earth. It makes moving the mass of air turn right in the northern hemisphere and left in the southern hemisphere. It's maximum at the pole and minimum at the equator. The geostrophic wind is the wind which is blown as a result of a balance between the geostrophic force and the pressure gradient force, at 2,000 feet for example. It blows along straight isobars. Turbulence. Turbulence reporting criteria. Occasional is less than a third of the time. Intermittent is a third to 2/3 of the time. Continuous is more than 2/3 of the time. Light is not shown on significant weather charts, but includes changes to altitude, attitude, pitch, roll, yaw, where the aircraft remains in positive control. Moderate, there are greater changes to altitude and attitude, pitch, roll, yaw, and the aircraft still remains in positive control. Severe, there's large changes to altitude, attitude, pitch, roll, yaw, and the aircraft is momentarily out of control. Sea breezes. The sea breeze is wind blowing from the sea during the day. The land is heated and the air rises, resulting in high pressure aloft, with a movement of air at around about 500 to 1,000 feet from the high pressure aloft to the low pressure altitude over the sea. This descends, resulting in high pressure over the sea, which then moves inland and is known as a sea breeze. The reverse is the land breeze, where there's a warm sea results in high pressure aloft, and a movement from the high pressure aloft over the sea towards the land where there's lower pressure altitude, which descends over the land, resulting in high pressure at the surface, which then forms a land breeze blowing from the land to the sea at night. Backing and veering. Veering is a clockwise change in direction of the wind. Backing is an anti-clockwise change in the direction of the wind. It's the same in both hemispheres. Ballots Law. If you stand with your back to the wind in the northern hemisphere, the low pressure is on your left. In the southern hemisphere, it will be on the right. During the day, the surface wind increases and veers, and at night it decreases and backs in the northern hemisphere. Winds. The katabatic wind is a movement of cold air descending down the mountain by night. An example would be the Mistral or the Bora. An anabatic wind is a movement of air ascending up the mountain by day. A ravine valley funnel wind is wind blowing in between mountains through a gap or valley, for example the Mistral. The föhn wind is a warm descending air down the leeward side of the mountain. The example would be the Chinook in the Rocky Mountains of Canada or the Santa Ana in Los Angeles. Backing factors for the Northern Hemisphere. The surface wind compared with the 2,000-foot wind. During the day, there'll be 20 degrees of backing comparing the wind at 2,000 feet with the wind at the surface, and the wind will be half the strength. At night, the backing is 40 degrees and 1/3 wind speed at the surface. Over the sea, there's no distinction between day and night, and the backing is 15 degrees and 2/3 of the wind speed.